Okay, so before you do the speed calibration of your locos, we need to set the decoder. Now, on non-sound decoders, what we need to do is set CVs 3 and 4 to a value of 0. These values are acceleration and deceleration rate of the loco. Now, when we do the speed calibration, if we don't set these back to 0, and it's going across the detectable section to record the speed, it might still be accelerating, ramping up to the actual speed step that we're trying to record. So then when it gets halfway through the speed, the calibration zone, it will only have just got to the speed step's correct speed. So then that speed step's wrong, because it would have taken half of the feedback at one speed and the rest of the feedback at the true speed. So if we reduce these down to 1 or 0, then at least when it's in the detectable section, we're getting a constant speed of the loco at every speed step. This is vital to make the calibrations work right. So you must set CVs 3 and 4 to a value of 0. The other thing you probably want to think about is the maximum speed that particular loco is going to run. So to make use of all the speed steps, if your loco, you want to drive at maximum speed 100 miles an hour, but if you've left CV5, so maximum speed is the maximum amount of volts it's delivering to the motor. If you left that on a value of 255, the loco could go maybe scale speed 200 miles an hour. Well, then you're not making use of all the speed steps if the loco is only going to be running at 100 miles an hour at maximum speed. So if we reduce CV5 down to that point where it's driving at 100 miles an hour, you now get all the speed steps, let's say 28, between 0 speed and 100 miles an hour. So that's smaller steps, and you can use all of the steps. If you'd left it at 200, the steps would be bigger because they're bigger increments to get up to that speed. So if we reduce CV5 down to 100 miles an hour, then we have smaller steps. That's crucial. Now, if we do reduce it down, we must also think about mid-speed. So that's the mid-speed, CV6. So CV6 mid-speed. We want to reduce that down to create the speed curve and where it gets its mid-speed from. If you have it half of 100, so say 50, you get a linear line. That's fine for controlling an iTrain, because after we've done the speed calibrations, we can adapt the characteristics of how the loco accelerates within the locomotive editor section. So this is a vital step you must not forget to do whilst setting the loco up. We can show you how to do it in iTrain. So this is decoder programming in iTrain. If I get out of shot a minute. So we've got a class 68 loco on the program track. If you wanted to change CV acceleration, these two. So if you want to change this one, you can put in a value. So say it had been 50. I'll just write that to the decoder. So that would have been the acceleration was in there. We wouldn't want that. So all we do is highlight it, press in 0 and go right. That then sets that value of CV3 to 0, deceleration rate. So this is not so important, because if it's decelerating, it would just go a bit further out of the detectable section. So if we wanted to change that CV, again, we can read it by pressing read when it's blue, and it will read back the value it's set at present. If you want to change it, double click in there, change that value to 0 and hit write CV. That then changes that CV setting in the decoder. So these are the main two that we need right to get the speed calibration. Then we can look at maximum speed. So if you want to reduce the maximum speed this loco runs on your layout to make use of all the speed steps, let's say we want to put in a value of 100, we write that. That's now written. And then mid speed, I'm just going to do it half that so we get a linear curve. The other one, minimum speed. What this is the minimum amount of volts at which it takes to drive the loco at speed step 1. This, you literally want it, so at speed step 1, it drives without being jerky movement. So just increase or decrease this, have it as little as possible, but make sure it is a smooth movement, not juddering, because that just looks terrible. So that's how you would do the programming of CVs in iTrain. We'll apply that. Once you've applied it, and we leave this screen and we go to edit locomotives, then all those CVs under configuration are set and saved in the database. So you can save all of the CVs in one place for that loco.